Hello, let's do the New York Times Medium Sudoku for May 9th, 2024. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay, so let's go over some terminology first. These are cells. There's 81 of them in the grid because there's 9 by 9 grid of cells here. Each of these individual things we call a cell. They're kind of the building blocks of the whole Sudoku. Each cell will have a digit in it at the end of the puzzle. No cell will be left blank. Now, this is a row, this is a column, and this is a box. There are 9 of each, and within each row, column, and box, we're going to be placing the digits 1 to 9 exactly once each. So the important bit is that exactly each of these cells will have one of the digits from 1 to 9 without repetition within the row, column, or box. Okay, and in addition to that, the only other terminology you need to know right now is we have bands and stacks. So a band is a row of 3 boxes, just a convenient way to reference that structure. And a stack is a column of 3 boxes. Now, since a band, we're going to focus on the bands first. And stacks work the same way, just rotate everything 90 degrees. So if I say row, think column instead if we're talking about stacks. So a band is going to have 3 of each digit, right? You can see it's made up of 3 rows, and each row has 1 of each digit, so we're going to end up with 3 of each digit. It's also made up of 3 boxes, which have 1 of each digit, so that agrees. It's going to be 3 of each. So what we want to do in our first pass on these bands is we want to look for when we have exactly 2 of a digit in a band, but not the third one. So in this band here, the only example of that is these 4s. So we have 2 4s that are known where they are in this band. We need to find the third one. Now, can you localize where that third one will go? Well, if you think about it, each row has a single 4, and each box has a single 4. Now, this row and this row already have a 4, so the third 4 must be in this row. Additionally, this box and this box already have a 4. We call this box 1 and box 2. So box 1 and box 2 already have a 4, which means that the final 4 is going to be in box 3. So if it's going to be in row 3 and box 3, it needs to be in the intersection of those. So it's going to end up in one of these 3 cells. Now we can prove that in another way, which is a little bit more convenient. But I want to make sure you're understanding the way to think about the puzzle in a more global sense, where we can reduce where things need to go in a logical way, thinking about the basic rules of the Sudoku. But here's another way we can think about it. This box does need a 4. It's going to be in here somewhere. We don't know where it is yet, but we know it can't repeat in this row, and we know it can't repeat in this row, and they already have 4s. So there's only one row within the box that can have a 4, so that's where it's going to be. So one of these 3, in the final solution, one of these 3 cells will be a 4. Now, we want a nice way to remember that, but we can't just randomly decide one of these cells to be a 4. We are not playing a guessing game here. Sudoku is a logic puzzle, and we can use logic, concrete logic that 100% proves every digit that we place. But along the way, there's pieces of information that aren't exactly a placed digit that we still want to remember. So in order to remember that, we're going to use the corner mark mode of Sudoku Pad here. And I'm just going to corner mark 4s into all 3 of these cells. Now, what a corner mark means is that within this box, corner marks are box-centric marking, the way that we use it. It's obviously just by convention. But the way we're going to use corner marks is that they are a box-centric marking, meaning they mean something about where that digit goes in the box. It's exactly what I just described. Within box 3 here, the 4 is limited to just the 3 cells that I have marked with corner marks. Now, we could mark every digit in every box with corner marks if we wanted to, but I do not recommend doing that. We're only going to mark it if it's down to 2 places in the box. We'll mark it no matter what. If it's down to 3 places in the box, we're only going to mark it if they're all in the same row or all in the same column. So in this case, they are all in the same row. So that is something we mark. And that's always going to be the case when we find it this way, through what I call buddies. This 4 has a buddy, and that's going to cause the third 4 to be corner markable or placed. Okay. So that is the only other repeat. Now, a nice way to scan for that is to start with the box with the least number of givens in it. In this case, this box has just the 1, 9. And we would just look. So in this case, we just see it's a 9. So we look for a 9 in one of these other 2 boxes, and we don't see any. So now we just have to compare these 2 boxes against each other. And we're going to pick, again, the box with the fewest givens, if they're not equal. and we think about 4 and 8, and we look for a 4 and an 8 in here. And the 4 is the one we found. And now we know comprehensively that there are no other repeat digits that we maybe didn't notice. So we do want to move on to the next band, but before we do so, there are two things to look for. The first thing is if you have a completely filled box row. A box row is just the intersection between a box and a row, right? They're the row of a box, right? So none of these are completely filled with known digits. And so we can skip that. And then the last thing to look for before moving on is a row or a box with 4 or fewer open cells. So this box has 5 open cells, 1, 2, 3, 4, 5. So that's not a candidate. This row has a bunch. This row has a bunch. So none of those qualify. So all we got were these corner marks on this top band. We're going to move on to the next band. This band might be nicer. So we're going to start with the box with the fewest givens, the 2 and the 7. We're looking for 2s and 7s. We see a buddy 2. So this 2 and this 2 are looking into this box like this, right? So the last 2 is going to be up here somewhere. But obviously this 9 can't be a 2 because it's a 9. We can't put 2 digits in the same cell. And then if we scan up and down, we actually see that we have some 2s helping out. We have a single 2 helping out down here. So this 2 says it's also not here because we can't repeat the 2 in the column. So there actually is only one cell in this whole box that can be 2. And since the box needs a 2, it needs every digit, we can place it because that cell must be 2. If we didn't make this cell 2, there wouldn't be anywhere to put 2, and we've already broken the puzzle. So we placed that 2. Very nice. So that was the 7 and the 2. This is the kind of thing we're looking for, right? That's why we're doing this. So in this box, we have the 1, 2, 3, and 9. We already dealt with 2s, so 1, 3, and 9. I see that we have a 1 and a 9 here. I'm going to take them one at a time. I like to do them in numerical order so I don't lose my place. So we do have 2 1s looking into here. Now, that 1 is limited to these 2 cells, so we're going to corner mark that. And then we'd also have the buddy 9s. They look into here, and this 9 looks up, so 9's one of these 2. We'll corner mark that as well. Now, before we move on, we want to look for filled box rows, and we do see one over here, this 165. So what we want to do is we want to do a special scan for this, which I call virtual buddy scans. I'll explain that in a second, but we're focused on the 2 rows and 2 boxes, that intersection, that aren't the filled row. So these right here. We're ignoring any empty cells, and so we just have the 1, 2, 3. We're also ignoring anything that's already placed in the box, so the 1 and the 2 don't count. But we did find this 3. So what I want you to do is look at how this 3 affects the box. Well, it takes 3 out of these 3 cells, but also these 3 cells, because they were filled with non-3s, also can't be 3. So it's as if we had a virtual buddy 3 over here somewhere, in the same row as the filled row, and in the box that doesn't have that 3 in it. So it's as if there was a 3 over here, taking 3 out of these 3 cells, along with this 3, and then this 3 looks in. So we can actually place this 3 here. And by placing this 3, we actually prove that that virtual buddy is actually real, and we can corner mark it. There will be a 3 up here, because these 2 3s look in this box, leaving just those 2 for 3. And that's always going to be true. That virtual buddy that we found is actually there, and we can mark it. Okay, so that deals with that filled row. Now we want to look for rows or boxes that are down to 4 or fewer open cells. First thing I see is this box is down to 3. Now what we're going to do is we're going to center mark the box. But first we're going to think about what those digits are. So we have 1, 2, 3. We need 4, 7, 8. So we're looking around for 4s, 7s, and 8s. And I do see we have this 8 here, taking 8 out of this cell. So that does leave only 2 cells left for 8s. We can corner mark those. Now when we do that, that does do something a little bit special called pointing. Because what we've done is we've said in this box, the 8 is going to end up in this cell or this cell. And so of those 2 cells, both of them, they share a column. Both of them are in column 9. So no matter where this 8 ends up, it will be the 8, not just for the box, but it'll be the 8 for column 9 as well. It'll be the 8 for this column. So if it's the 8 for the column, we can't have other 8s in the column. That's not allowed. And so actually, these 2 cells cannot be 8. Importantly, this one can't be 8 when we thought it could. We do have all these other 8s looking in as well. And so because none of these are 8, we can corner mark 8s in this box up here if we want to, which we do. Okay, and because we already scanned this box here, it's worth looking to see the effect of that, right? Okay, but back down to here, the remaining cells aren't restricted in any way, but we want a way to remember that. And so what I'm going to do is I'm going to use center marks. And I'm going to center mark the 4, 7, 8 here, and I'm going to remove this 8. And what center marks are, is they are cell-centric markings. If you were probably thinking about how to mark up a Sudoku, this is probably the kind of marking you would do. What this marking means is that this cell, its final digit its digit in the ultimate solution is going to be a 4 or a 7, guaranteed. It will not be any other digit. It will be a 4 or a 7, because we know we can't repeat digits in the row, column, or box, and so we can't be the 1, 2, 3, 5, 6, 8, or 9, right? If it can't be any of those, the only digits I didn't list are 4 or 7, 4 and 7, and so those are the only two digits that can even go in that cell. So it's a very cell-centric marking. And whenever a cell is down to 3 or fewer, what we call candidate digits, 3 or fewer candidates, that is worth center marking. So that's what we did here, because we knew it would be down to 3. Same for this row. We know this row is down to 3 digits remaining. And so these cells will be center marked with at most 3 digits. Now, what are those digits? The 3, 4, and 8. Always good to think about it first. So I'm seeing that this cell can't be 3. We already have that corner marked over here. So that means that this is only 4, 8. Now these are down to 3, 4, 8. I see this 4 has an effect, but I'm just going to fill 3, 4, 8 and then remove the 4. Okay, so perfect. We dealt with this row, which was down to 3 open cells, and we dealt with this box that was down to 3 open cells. This is down to 5. This box has a bunch. So yeah, there's nothing else to do in this band. So we're going to move on to the next band here. All of these boxes have 3 digits, so I'm just going to start here. We have 3, 4, 9. We're looking for 3, 4, 9 over here. I do see the 3 has a buddy. So the 3 ends up in one of these two. The 4 does not have a buddy, but the 9 does. We have these 2 9s. We also have this 9. We always peek up and we look for 9s up here. We have these 2 9s looking down. That does place the 9 in this box. We call that a hidden single, by the way. Hidden meaning we're looking at a row, column, or box in order to discover it, and single meaning there was only one place left. So a hidden single, it means we can place the digit. So a hidden single in this case means there was a single cell in the box that could be 9, so it must have been 9, so we placed it. So that was the 3, 4, 9. Now we look at the 2, 7, 9. We already dealt with 9. There is no 2, 7 over here. So that's it for the buddies. We look for filled box rows. We do not see any. And we look for rows or boxes down to 4 or fewer open cells. And I do see this row is down to 4. So what are those 4 digits? Now, because it's 4, we're not going to automatically center mark it, but we do want to think about it still. We need the 1, 4, 5, and 6. Now, I see that neither of these cells are 4, and I was very hopeful that maybe one of these two also couldn't be 4, but unfortunately not. But because these can't be 4, they're already worth marking, because they're down to 3 digits now, because then we know they can't be 4. So we were down to 1, 2, 3, 4, 5, 6. 1, 5, 6. And this can't be 6 either. We have that 6 there. And whenever I center mark, I am looking around at the rows, at the columns, at the boxes, to see if there's any like buddying up for center marks. And when we do find something like a pair or a triple, I will point it out. And so it was 1, 4, 5, 7. Sorry, not 7. I think I missaid it over here. Yeah, sorry, it's 1, 4, 5, 6. This can't be 1 or 6, so this is down to 4 or 5. And this can be any of 1, 4, 5, 6 as far as I can tell, so we aren't going to mark it. Okay, any other rows or boxes down to 4 or fewer? I'm not seeing any. So we can now move on. And so now the next phase is do the exact same thing, but with our stacks. So just anytime I said row, just replace that with column. And we're going to go stack by stack. So I'm going to start with the 2, 7 here, the least populated box. So the 2 does have a buddy way up there. These 2s look down. We have this 2 looking in. So 2's in one of these 2. We also have the 7 buddy down here. These 7s look down. This 7 looks in. We have a 7 in one of these 2. Now, something very special just happened, which is that we found what's called a hidden pair. The way a hidden pair works is that in this box, we have discovered that these 2 cells are the only 2 cells that can be 2. They're also the only 2 cells that can be 7. The same exact 2 cells. Well, we need 2 cells for the 2 and 7 in this box, and the 2 and 7 must appear in the box. So it's kind of like a matching up, right? We don't know which one will be 2 and which one will be 7, but we know that they will end up being 2, 7 and nothing else. And the reason for that is not because they directly see all the other digits. It's because if they were anything else, we would not be able to fit both 2 and 7 in the box. Therefore, these overlapping corner marks are telling us just kind of directly that we have found a hidden pair. because the corner marks are only in these two cells and it's 2 digits. So what we can do is we can center mark that as 2, 7, which is more powerful than the corner marks. Because what we found here is a 2, 7 pair. We know that this cell will only be 2, 7 and this cell will only be 2, 7, meaning we've removed a bunch of possible candidates from those cells. For example, we've removed 1, 5, 6, 8. Now they already couldn't have been 6. This one already couldn't have been 1. But 1, 5, 8 in general were removed. And so actually I am seeing, we see that there's 4 remaining cells in this box, and they are exactly those digits, the 1, 5, 6, and 8. Now we know neither of these can be 1. And so now what we've actually done is we said, well, this one looks in and these can't be 1. It's kind of like we had that filled row, box row. But the reason this can't be 1 is from the simple fact that it has to be a 2 or 7. Since it has to be a 2 or 7, it can't be a 1. So none of these are 1. That does put a 1 up here. And then that's going to point into this box along with this one, and this one looks down, and we're going to get a 1 on one of these two. Remember, pointing is when we've restricted a digit in the box to a row or a column, in this case a row, and so the rest of that row can't be that digit. So now we know this can't be a 1, so it is down to just 4, 5, 6. We can mark that. We also know these are down to 3 digits because they aren't the 1. So they are the 5, 6, 8. And we know that one of these two is an 8 because the 8's not up here. Because one of these two is an 8, that does point in here along with this 8. This 8 looks down. We can corner mark 8s in one of these two as well. So this hidden 2, 7 pair did a lot. Did a lot for us, right? It allowed us to mark up a bunch of stuff in this band that we didn't otherwise know. Okay. No direct digits yet, but I promise you it'll come in handy. So there's one final thing that I noticed that we did, and this is one of the hardest things to notice, but I do want you to be on the lookout for it, because if you can spot it, then you have found something very important. And it's going to help a lot with the puzzle. So when we corner mark these ones, what we want to do is we want to scan upward to see if any other box has ones restricted to the same 2 columns. So the 1 is restricted to columns 1 and 2 in this box, specifically here. And in this box, the 1 is also restricted to the same 2 columns, columns 1 and 2. We know that this box is going to have one of the 1s, and this box is going to have one of the 1s. So really, where's this box's 1? And the answer is it has to give it to column 3. This is called claiming. And if we inspect column 3, this was just a nice way of noticing that if we inspect column 3, none of these cells can be a 1. We do have these 2 1s helping out. In this one as well. We have these 3 1s helping out, removing 1 from those cells. And this 7 can't be 1. So actually in this column, the 1 is limited to these 2 cells. This is very similar to pointing, but it's called claiming because it's the opposite. Pointing is when we've restricted in a box to remove from a row or column. Claiming is when we've restricted in a row or column to remove from a box. So we can actually corner mark the 1s in here. And you may be thinking, I thought 1s were related to boxes, not to columns. And yes, they are related to boxes. And what this is telling us is that the rest of the box can't be 1. Because we need the 1 to be in column 3 so that column 3 gets a 1. So column 3 has claimed the 1 from the rest of the box. It's called claiming. Okay. So these cannot be 1. And that's the important deduction that we may not have understood previously. So I'm wondering about this cell here, because we know it can't be 1, 2, 3, 4, 6, 7, or 8. So I'm noticing this cell's down to 5, 9, and just because I noticed it, I am going to center mark that. That seems pretty nice, because we removed 1 from all these cells, so it seems useful to think about the consequence of that. Okay, I'm not going to think about the other ones, though, because I don't think they're as restricted. Alrighty, so we were scanning this band, or this stack. All we did was the 2 and the 7. That gave us this. We still have to compare these 2 boxes against each other for buddies. So the 3, 4, and 9. We do have a buddy 4. These 2 4s look in. We look over here for 4s, don't see any. So 4 ends up in one of these 2. Now don't get confused. This is not a hidden pair because the 1 and 9 can escape over here. The 1s and 9s are like this. We need them exactly overlapping only in 2 cells to get a hidden pair. Okay. So that was the repeats for the stack. Last thing we look for before moving on is filled box columns. We do not have any. And we are also looking for columns or boxes down to 4 or fewer cells. This is down to 5, so that's not one of them. This box is down to 5. So yeah, I don't think we have anything else there. Move on to the next stack. So I'm going to start with this 4, 8. We do not see any 4, 8s down here. So now 2, 7, 9. We do have 2 2s looking up, and this 2 looks in. That places this 2. Now, as soon as we place that 2, what we want to do is we want to think about how that affects the stuff we already scanned, specifically this band. Because now, if we rescanned this band, we would find that we actually have a buddy for this 2 now. So we want to act on that. So we have all these 2s looking in. 2 is corner marked here. Again, not a hidden pair because the 4 can escape here. There needs to be no escape in order to really lock down that hidden pair. Okay, so that was the 2. Following up on that 2, did it fill a box row? It did not. Did it cause a row or box to be down to 4 or fewer? It did not. Okay, so that was the follow-up on that. We also had the 9. We have these 2 9s looking up. This 9 looks in. Puts a 9 in one of these 2. Whenever we do this, we do want to scan left and right to see if we ended up matching up 9s, right? But we already have this 9 placed, so it's not important. We don't really have to look for that. Anyway, I just thought I'd point that out. 2 7 9, 2 9, 1 3. So I think that's what we get in terms of buddies. That is what we get in terms of buddies. Filled box columns, no. Columns or boxes down to 4 or fewer. This column is down to 4 digits. So what are they? They are the 1, 5, 6, 8. 1, 5, 6, 8. I'm seeing this cell can't be 1, so I'm going to fill 5, 6, 8 there. Neither of these can be 8. So these are 1, 5, 6, and this also can't be 6. So I'm desperately looking to see if the 1, 5 has a buddy, if the 1, 5, 6 has a buddy. I haven't seen any pairs of triples yet. I remembered there was a 1, 5, but it's over here, so that doesn't help us. They need to share a row, column, or box. Okay, any other columns or... Oh, this was all of them, right? 1, 5, 6, 8. It looks like it. So we don't mark that one. Any other columns or boxes down to 4 or fewer? I do not see. If so, yeah, I don't think so. So we're going to move on to this final stack over here. Start with this 9. We have all of our 9s, so we just compare these. So we need the 1, 3, and 8. So the 1 and the 3 do have buddies. So these 2 1s do look up. It puts a 1 in one of these 3. And then the 2 3s look up, putting a 3 somewhere up here. That's all the buddies. Any filled box columns? Yes, this is filled. So actually we already got the 8s, but this is the point where we would get the 8s if we hadn't already. Okay, that's the only box column that's filled. Any columns or boxes down to 4 or fewer open cells? I actually don't see any, other than this that's already penciled. Okay, so we did not finish the puzzle. So our initial first pass scan, sometimes we finish the puzzle that way, sometimes not. It's perfectly fine if we didn't. It just means there's something a little bit more subtle that we missed. So what we want to do is we want to go on a hunt. So what I'm going to start with is I'm going to go box by box. And there's just sort of a few intuitive things that we want to look for when we look at these boxes. The first thing is something I call crossings. But basically what we're looking for in this next pass is something internal to the box that we may not have noticed from a singular band or stack. It's kind of the band and stack working together, right? So crossings are a really common thing. They're not that common, but they're pretty common. And it's when we have 2 givens in a box, like this 2, 4, and we find something in this row and these columns that match up, that restrict a digit significantly in the box. So this 2, 4 does not have any, so that's not a great example. We can also look at like this 4, 6 here. So this 4, 6 does have one, because we have a 9 in this row here and a 9 in this column here. The row and the column that they don't occupy, those are the ones we're interested in, and we're interested in repeated digits in those. And so this 9 here is going to take 9 out of these 3 cells, and this 9 over here takes 9 out of these 3 cells. And that's a 5 in total because they overlap in one cell. But the 4 and the 6 are also not 9. So there actually are only 2 places in this box for 9, so we're going to corner mark that. Now I did notice it lines up with these 9s, but we already have the 9 in this column, so that's not important. But I did notice it, just want to point that out. So maybe this, we're not going to get anything else out of this row because the 4 and 9 are already taken care of in this box. Also, this 2, 4, 9 is not going to help. The only thing that could possibly help is this 3, but there's not a 3 over here. So we know it's safe to move on. Now over here, we already have the 9s marked. We got that taken care of. The 2 is not going to help. This 4, 8, yeah, so this 7 looks through. But this 7 hits the 4, right? So it's not good enough. We need something over here. So the 1 would really be the only thing that could be useful hitting this box, and unfortunately there's no known 1 up on this top row. So we can't do anything with that. So we're going to move on to this box. Now, this box doesn't have a bunch of givens in it, but something I will point out about this box is we have quarter marked a lot of digits in this box. We've quarter marked the 1, 2, 3, 4, and 8. And none of them touch this cell, meaning this cell is not 1, 2, 3, 4, 8, or 9. So it's not 1, 2, 3, 4, 8, 9. It's already not 6 of the 9 digits. And it also, I noticed, isn't the 5, right? So it's even less than that. But it's already down to at most 3 candidates, so it's safe to center mark it. It's not 1, 2, 3, 4, 5. It could be 6. It's not 7. It's not 8 because of these pointing 8s or claiming 8s here. And it's not 9. Oh, so is it a naked single 6? Let's double check. 1, 2, 3, 4, 5, 7. It's not 8, 9. Okay, so it is a naked single 6. So that's why we look for it. And that removes 6 from this cell. Now, as soon as we do that, we want to notice that that causes a 1-5 pair. Now, this is called a naked pair because what has happened is we have penciled all the candidates for this cell and found they were only 1 and 5. We've penciled all the candidates for this cell and it's also only 1, 5. When we say a technique is naked, we mean we're looking at the center marks. We're looking at just the possible digits that those cells have been narrowed down to. And you may notice that because they share a column and also because they share a box, you cannot repeat digits in them. They can't both be 1, they can't both be 5. So since you can't repeat digits in them, we know that one of them will end up 1 and one of them will end up 5, either like this or like this. Now we don't know which order they'll end up in, but the rest of the column does not care. The rest of the column is gonna have a 1 and a 5 up here looking at it. Whether this is 1, 5, notice this can't be 5, this can't be 1, right? Or this is 5, 1, this still can't be 5, this still can't be 1. And those are the only 2 options. That's how these are going to resolve. Because they need to both have digits and they can't have the same digit as each other, and 1 and 5 are the only digits available to both of them. So this actually cannot be 5, we can remove 5 from here. And this cannot be 1, meaning we can remove the 1 corner mark. Now we removed a corner mark, meaning we need to look at the box, and we see that there's only 1 corner mark left for 1. So that actually is a hidden single, and we can place the 1 in the box now. Very, very nice. Now we know this is down to 6, 8. We can mark that. That's just the rest of the column, because it's not 1 or 5, so it's down to just the 6, 8. So we're looking to see if the 6, 8 does something. We're looking to see if this 6, 8 does something. We're looking for pairs, triples, things like that. We're looking to see if maybe we already have the 1s done, but maybe the 5 had a buddy. We know the 5's up here now. So are there any other 5s that are known? There are not. So that's also not helpful. We're also looking to see the effect on this box. This box now has 4 open cells because according to the box, the 1 and 5 are here. These cells don't care which order they resolve in, right? They can't be 1 or 5. So it's down to 4 digits. What are the 4 unknown digits in this box? They are the 3, 6, 7, and 9. Now I already know these can't be 9, so I can mark 3, 6, 7. And then this can't be 7, so this is, or 6, so this is only 3, 9. And this can't be 6. So this is 3, 7, 9. And now I notice that because of these 2 6s that I didn't quite follow up on, we do end up with 6 in one of these 2 cells. So that's helpful. To an extent, it's helpful. All right, so that box got taken care of. We are following up on this naked 6 that we got. So we wanted to make sure we found the buddy. We also we followed up on this 1, 5 pair first. So is there anything else to follow up on? Did it fill up a box row? It did not. Did it fill up a box column? It did not. No, we want to see how it affects the stack as well, because we've already scanned the stack. You can see it does have a buddy in the stack. And so now it places a hidden single 6 here. Definitely don't want to forget that. That removes 6 from these 2 cells, and it causes a 5, 8 pair. Well, that 5, 8 pair tells us that 5 and 8 can't be up here anymore. Because again, this naked pair in the box, the naked pair affects the whole box because they share a box, right? This does not care. If this was a 5, notice what would happen here. These would both have to be 8, or one of them would have to be empty, right? This cannot be 5, and this cannot be 5. So this ends up being the 1, which then makes this a 6, and that makes this the 1. Oops, oh, I did not mean to do that. Sorry. That makes this the 1. Okay. Now this 6 comes back around, leaving a 4, 5 pair behind here. So we just got the 6 and 1. We want to see if we can follow up on that. Well, we do have these 2 6s looking in. it puts a 6 in one of these two cells. Now, hopefully you saw what just happened. We just found a hidden pair because we have these two overlapping corner marks. So this is a 6, 8. We don't need the corner marks anymore. So this 6, 8 pair tells us that 3, 4, 5 is what's left for this box. But this 5, 8 pair removes 5 from these two cells. So this 5, 8 pair tells us these can't be 5. And this hidden 6, 8 pair tells us those can't be 5. And these aren't 5. So there's only one place left for 5 in this box, which is here. So we can place the 5 and the 4 here. That 4 looks up, removing this 4 corner mark. That leaves 4 in just these two cells. Coming back around to here, this is going to be a pair as well for the box. It's going to be 3, 3, 4, it looks like. Okay. And then this is going to be 2 or 7, because that's what's left. We have a 5, 8 pair, a 3, 4 pair, and then the remaining pair is 2, 7. So we can fill 2, 7 here. This whole box needs a 2, 5, and 7. 5, this 5 looking down tells us 5 goes only here. And this is also 2 or 7. Okay, so we're doing quite a lot, right? We're at this point, I think the best thing to focus on is restricted rows, columns, boxes. Rows, columns, boxes with 4 or fewer. The fewer, the better. If you can find one with, say, 3, like this one, that's better to look at first than to look at one with 4. So we are going to be jumping around a bit. But this column is down to 5, 8, 9. And we're looking to see if any of those are restricted. They aren't. So it's just 5, 8, 9. This column here is down to 5, so we don't care about that. All right, this column here is down to 2, 4, 7, 8. I think it can be any of them, though. Oh, no, it can't be 8. That's important. So it's 2, 4, 7. Yeah, the 8 is down here. Okay, so we're still on the lookout. We might have to go back to box scanning. We may not have found enough yet, but I'm looking to see if we have any more. Yeah, so this column here is down to 4. So we're down to 3, 4, 5, 7. So we know the 5 is restricted up here. Yeah, and if I'd followed up on this 5, we would have seen that. Let's see, does the 9 or the 6 follow up? No, we already have all of them. The 5, the 4. Yeah, we know the 4 is here. Okay. So we get the 5 up here, and we know in general these are 3, 4, 5, 7. This can't be 4 or 7, so this is only 3, 5. Oops. Meant to center mark that. This can't be 4, so this is 3, 5, 7 for what it's worth. I'm on the lookout to see if this is 3, 5, 6, 7. So one of the easier ways to think about that is actually to think about the digits that aren't accounted for, right? If we're looking for a 3, 4, 5, 7 quadruple, that's kind of tough to find, like to know if these unpenciled cells are that. But if you think about what the two digits aren't, right? We have the 2, 4, 3, we have all of these digits marked up, right? What digits are missing? The answer is the 1 and the 8 are missing. We have the 2, kind of 3, 4, kind of 5, 6, 7, kind of 9, right? 1 and 8 aren't accounted for in terms of just markings at all for center marks. And so if 1 and 8 are down to just 2 cells, then we have found a hidden 1, 8 pair. Unfortunately, this cell can't be 1, but it can be 8. And this cell can be either. So we do not actually have that. But I thought I'd point out that might be a nice way, if you suspect a quadruple, to confirm whether or not there's going to be a quadruple. All right. This column's also down to 4. It is the 1, 2, 7, 8. This cannot be the 2 or the 7. So this is down to 1, 8. And of course, I'm scanning to see if there's any buddy 1, 8s or things like that. 1, 2, 7, 8. This can't be 2, so this is 1, 7, 1, 7, 8. And this can't be 8, so this is 1, 2, 7. So this is quite busy, but unfortunately it doesn't do anything. Busy that doesn't do anything is the worst. Okay, so I still haven't found what I need to find. So I'm going to continue looking through. I don't think we have any more rows, columns, boxes down to 4 or fewer. So there's something that I'm missing that I didn't account for my initial scans. So it might still be box by box. So let's look at this cell, which is avoiding the 3, 4, and 9. So what can this cell be? It can't be 1, 2, 3, 4. Let's highlight the cell we're looking at. It can't be 1, 2, 3, 4. It could be 5. So let's fill that. It could be 6. Can't be 7, or 7 in the box if you prefer. I think it could be 8, and it can't be 9. So we're down to 5, 6, 8. Okay. We have so many almost triples going on here. This cell can't be 6 or 8, and I know the column needs that. So this is down to 1, 5, 6 only. Oh, it's down to 1, 5 only. Sorry, no, I miss. Okay, let's look at what it can actually be. It could be 1, it can't be 2. I think it's 3 that it could be 3. It can't be 4. It could be 5, can't be 6, 7, 8, 9. Yeah, okay, so I missed the 3. 1, 3, 5. This just can't be 6. Ah, okay. So what I've noticed by staring at this column long enough is that 6, I did not notice we had these buddy 6s. So I did not follow up on this 6 properly, and had I done so, I would have saved myself a huge amount of headache. This cell is a hidden single 6 in the box. That does make this an 8, which makes that a 4. That makes this 3 and 4. That makes this 6 and 8 from this 8 here. This none of these are 3 anymore. So that gives us the 9, the 7, the 6, the 3. There's a lot to do now. This just collapses everything. I'm sorry for missing that. This 8 looks over. Removing 8 from here, that places this 8. These aren't 7. Let's just start cleaning up a little bit. This is not a 3. I saw some easy stuff here. Okay, this is not a 9 anymore because of the 9 in the row. So there's only one place for 9 in the box. We can place that. That leaves only one place. So I guess that makes that the 5 and the 8 and the 5. There's only one place for 9 in this box now because we removed a 9 corner mark. So that's the 9, which makes this the only place for 4. We're left with the 3, 8 pair here. This 4 resolves this 7 and 4. This 4 resolves this 2, 1, 8, 7, 5, 3, 4. Whole box resolves. This is 5 and 1. That's a 3. That's a 1. That's 8 and 3. All right, this definitely finished the puzzle. This is 2 and 7, which gives us the 7 and the 2 here. And then up here we need a 5, which goes here, and we need a 8. And then here we need 5, 6, 7. So the 7 goes here. This is the 5 and the 6. All righty. So yeah, it was lack of follow-up. Whenever I placed the 6, I did not follow up on it in the stack. Maybe there was something exciting to do in the band, and I forgot to follow up in the stack. And by doing so, I missed that we had these buddies. I would have immediately placed the 6, and that would have saved us a lot of headache. It could have actually finished the puzzle significantly faster. But you did get to see kind of the things I look for when I'm at the end and I'm still not figuring out what to do. Just go back to basics, start really laser focusing on each box, see if there's anything internal to that box that can be useful. Things looking into that box, just re-look for that stuff. Look for more subtle stuff like the rows and the columns working together, things like that. Penciling rows and columns that are down to only a few digits, or cells that look like they're specifically restricted. All right, so I hope you enjoyed this. And if you did, then why not leave a like, subscribe, and a kind comment below.